Hi my friends, and welcome back to our Semantic Manager courses. In previous lesson we wrote some logic in STL language, and in today's lesson we continue our lessons about the analog signals. And before we simulate it, let's simulate it and check our logic now, and then we continue to test. We continue test and make another example which also belong to analog signals. Now start our simulator and let's switch it to MPI and download our logic. Yes. Now our simulator is started. Let's switch to our OB1 blocks, and here let's now my friends, we can change the value. Here also is representative like the decimal, and now we have our input value. Let's change it from here and observe what happened. Let's make it 40, and now you see that our values is changed now. And now my friends, let's do the same in FPD logic or use some functional blocks. So let's stop our simulator now and stop it here, and now let's close it and open in OB1, and here let's add another network. Insert. Why he does that? Because let's do it. Insert network, and my friends, we can use the library from the S7, from the Semantic Manager general libraries, and can test and measure the analog signal via scale function, which the oven function of Semantic Manager, and you will faced with this function in many PLCs and DCS system in the future. And here we used, as I remember, the standard library, and here we use the T1S7 TI or TIS7 library, and here we have the function number FC103. No, it's not this function. Not 3, I think it's 5, maybe. Yes, this function, and let's add it here. So before, let's convert it to FPD, enable to convert network, because we have many operators in one network. And now let's add it again. Or this, do we want? No. Okay, now we added, my friends, let's delete it, because I think we made some mistake, and let's add it again. What is, do we want to overwrite this? No, I think. And after that, let's add our parameters for in we used, for example, PIV, which one we used in our PLC, PIV, okay, PIV 752, and for the high level let's use the 100, and for the, why it's not added, let's do it like this. Okay, now for low level let's add 100, and for bipolar, my friends, what does it mean? Firstly, to find it, let's open our help, and now we have some problems with the help. Okay, it's opened here, and let's open F, our function FC5, and found it. Okay, let me found it again. Index search FC0. Oh, topic found. Okay, let's find from here again. FC from context. Okay, values. Variables. Okay, my friends, I cannot find information about the bipolar in the help menu, but I know that it's here, but I cannot find it. Let me explain you what's the difference when you set the bipolar to 1 or to 0. And when you set it to 1, what happened? The signal or the raw data start to come from the 27,648 to 27,648, and when you set it to 0, it's come from the 0 to 27,648. Why it's happened? Because in some plants or in some equipment we have the signals that measure the set signal between the minus 10 volts to 10 volts to plus 10 volts. So you can use this signal if you set the true value or one value to bipolar parameter in the FC105. So let's continue, my friends. And my friends, we cannot set 0 directly here in this parameter. That's why we use our memory and the bit number 0 from our memory, and then we used our ret value where we will store our data. Let's use the MW50, and to out let's use the MD, I think MD60. And now let's save our project, and in our semantic manager we the function fc105 is appeared, and let's download it again to our PLC. Press yes button all, and now let's simulate our project again. Run P, set it for 0, and press this button and this one. Now we have 0 represent in decimal, and also for this one is also in decimal. And now let's try to change our value to 16, and okay, we change it, but our MV is not applied. Why it's 0? Because red val is the value where we store error from our input value. So I think if we set it to this value, we will get error, but no, it's not happened because it's still in the range of our data. Let's increase it to 5,000 and check. Yes, no, the same, we have no errors here now, but I think we're out of our range. Okay, let's do it like this. Copy and paste here. If we can do it, press. No, we have the same value now. Okay, let's do it like the 27,784, and let's check again. Now I think it's the 8, not 0, and now we get error from our scale box, and it set the number of error to red value, and you can find what's this number is representative in error table. So my friends, that's all for today. In the next lesson we talk again about analog signals, and next lesson is our last lesson about analog signals. And that's all for today. I wish you all the best, and I wish you good health and good like. Subscribe to our channel and hit the like button if you enjoy the video. See you in the next lesson.